All right. Hello, everybody, and welcome to the stream. I hope everybody is doing well tonight. We are going to pick up where we left off last night, and we're actually going to take this texture system update one step further. So we're going to get into that in just a minute. Let me see. Spiro, how's it going, buddy? Yeah, you got beat by LaFoley tonight for sure. All right. So before we get into what we're going to do on the stream, dude, want to just take a quick second and thank the supporters of the channel, beginning with our elite partners and partners, Javier Olazaran, Gerboles Inc., and Matt Oscard. Those are the two highest tiers of subscription over on YouTube memberships and Patreon, followed by the list of supporters you see here on the screen, which is a combination of the other tiers of support over there on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated and will help me cover things, like costs associated with running the channel and the project, things like hosting fees, software licenses, equipment costs, eventually, assets, things like that. So that is greatly appreciated. Along with that, of course, I appreciate each and every one of you viewers, whether you're catching us live over on the YouTube side or the Twitch side, or if you're just catching the VOD after the fact. I appreciate you guys. Without you guys, this project and channel would not exist. So thank you guys very much for being here, interacting with me, and following along with the project. I greatly appreciate it. Yeah, LaFolia, that caught you there, but I allowed it. Only because it was towards Spiro. And Spiro, I know Spiro can take it. All right, so what we're going to look at tonight is I did a little thinking offline, and LaFoley can actually take a little bit of credit for this as well. Passing around this structure for textures doesn't really make sense. Because we're passing it around in a bunch of different places, and I don't really think that it's completely necessary to do, because 9 times out of 10, or actually probably even more than that, we're not going to actually need to know really any of this information other than just, hey, we have a certain texture that we need to use, and then, use it, right? So my thought behind this is, things like the width and height can be queried, or the formats, or, what flags it is, array size, MIP levels, like all this stuff could be queried if we need it, right? And I feel like that's going to be an exception case. So, and that also includes things like the renderer texture handle, which I don't know of anywhere where we would actually need that outside the texture system, other than maybe the material system. We'll have to see. But my thought is, maybe we can completely eliminate this structure and just use an ID. Now, we do have this sort of unused internal ID here, which, kind of is sort of in the direction I'm thinking. But, this is just a U32, right? Which is, again, probably overkill, because I don't think we're ever going to have a situation where we need more than 65,000 textures loaded, right? I don't foresee that happening. So I think we can step the ID down to a U16, and instead of using this structure everywhere, we can go a more data-oriented route and keep all this stuff internal to the texture system. And reference textures, instead of a pointer, we can just use essentially a typedef U16 ID. And so that is what we are going to sort of step through and change this system to use before we actually implement it everywhere else, and sort of spread the changes out. And that'll make it a lot easier to pass things around, as well as the fact that we're not dealing with pointers to things, we're dealing with a much smaller type, and so forth. So I am going to typedef it just in case we do exceed that 65K limit. We could always step it up to a U32 if we need to in the future, but I really don't think that's going to be a problem. All right. Yeah, 65K textures. I really don't see ever having that many loaded. I've limited to 1024. Yeah. So, and typically our texture system config actually says what our max limit is, right? That's actually configurable. So once we actually have the game up and running, we can actually figure out, what the maximum number of textures ever loaded in the entire game is. Maybe go a little bit beyond that just to, have a little bit of padding or whatnot. And we can tweak that once we actually get ready to release the game. But I really don't think that... I think a U16 is going to be more than enough to handle anything that we need to throw at this. So... obviously a U8, I don't think is going to be, that's not going to cover it, right? I think we are going to have more than 256, obviously. So I think a U16 is sort of that sweet spot, right? So the way that I'm thinking about doing this is we have this sort of typedef struct K texture here. And instead of typedefing it as this struct, we are going to rewrite this to be typedefed as a U16. And then, we'll add our API endpoints here to go ahead and be able to fetch the data that we need for a given texture by that ID. Let's see. Diamond, how's it going? Good to see you. I made my handle a U16 too, but only 10 bits are the index and the remaining 6 bits are flags. I mean, we could do that. Although I have a feeling that we're going to have more than... I mean, we already do have more than 6 bits for flags, right? And I think we're going to be adding to these as well. Now, we could argue that this one is probably going to go away, but we already have more than that. And I think we're going to actually expand upon this as well. I think there's some other things I have in mind that we might actually need to know. So I'm not going to be able to do that, but I think that's fine. That is a good point, though. That is something we could look into if we ever needed to, but I don't think that's going to be a real issue. So what I want to do is I'm actually just going to, let's see, I guess let's take this structure as it is. And I'm going to actually go to the C file here. And we're just going to temporarily put this here at the top. Let's actually throw it right here. And we're going to have a fix me up here. Re-implement this DOD style. And we're also going to put a no check-in on that, right? So we don't want to allow that this actual change to go in when we go to commit. So instead of this, we are going to do a U16 as a K texture, right? And so this is basically just going to be an ID, which is going to be directly used for lookup. Now, you might be asking why I'm not using a handle for this. That is because I have actually not found a reason to maintain any sort of generation data. And if we do generate, or if we do maintain generation data, I suppose we could always, again, modify this typedef, but I don't think that's going to be a problem. So our entire API is going to still use K-textures, but instead of pointers to K-textures and treating it as a struct, it is going to be just a numeric, essentially. Isn't a generation useful if you update the texture externally? So you're talking about if we have it like an asset hot reload, right? I assume that's what you mean. So I've done a lot of thinking about that too. And if we have a asset hot reload, then that's actually going to trigger a callback into the texture system, which we don't actually have set up yet. But that is going to trigger an immediate GPU upload of that new texture data. And so whenever we actually have a hot reload, we're going to immediately handle that anyways. So again, since we're already uploading it to the GPU, based off of a hot reload event occurring, again, I don't really see a reason to actually maintain a generation. The renderer backend does maintain generation internally. But as far as the front end texture goes, as far as what the actual entire system is going to use, I don't think we need it at this level. So I think we're good without actually having that. Let me see. Also, boost your mic up 5 to 10%, maybe move it closer. So let me see. All right, I actually have my microphone. I think it's boosted all the way. Let me see. I think my gain is all the way up to it. Well, there's a little bit more. I doubt it's 10%, but maybe that's a little bit better. Yeah, I don't think it's going to get too much better than that. If I go any hotter than that, it's actually going to clip. So hopefully that helps. Is that any better? Singy, how's it going over there on the YouTube side? Adam, good to see you as well. The other question I have is I actually had my fan on a higher speed because it's a little warm in this room right now. So I wonder if that's affecting it too. Like maybe the noise cancellation is causing it to kind of fade off a little bit. I don't think so. Looking at the levels in OBS, it looks fine. So maybe I just need to be a little bit closer to it. All right. It's definitely louder. Okay. What if I sit like here? Is it still like louder? Because this is a little bit more comfortable for me, but if I need to get closer, I can. Okay. So, by the way, thank you for the follow, Miguel. Appreciate that. All right. So I guess what I'll do is I'll start off in the header file, and we will change all of these API entry points to use the new type, and then from there we can actually just do everything in the C file. So let me see. Texture system initialize, that doesn't need any changes. Shutdown doesn't need any changes. The texture callback does. So this is basically just going to no longer be a pointer, right? It's just going to be just that. So texture acquire, again, is essentially just not going to be a pointer, right? It's no longer a pointer to a struct. Now, that being said, the comments in this are actually going to be wrong, right? So we're saying a pointer to a texture to be loaded, to the texture to be loaded. So this is actually no longer a pointer. It's just the texture to be loaded, right? Can be a pointer. Let's say, I guess it's more of a texture ID, but I don't really want to call it texture ID all over the place because that kind of sucks, right? And also, how we represent this under the hood may still change again. So I don't necessarily want to call it that. Let's say the texture to be loaded, and then we'll say the default texture if not found, and then instead of 0 null if error, what we'll do is we'll say invalid ID U16 if error. May or may not be loaded yet on return, right? So that's true for the asynchronous function call. So I'm just gonna like copy pasta this down to all of the asynchronous functions. So there's one, and then here's another one, and I guess probably acquire with options. Okay, we don't have a comment on that one yet. Okay, so let's see. Param T here is going to be the texture to be resized. And then param T here is going to be just the texture to be written to. And then we'll just kind of work our way back up here through the comments. Let's see. So, we need to do the synchronous versions of this too. So this is going to be the loaded texture. Can be a pointer, let's see, can be the default texture if not found. And then instead of 0 null, we'll say invalid ID U16 if error. Maybe we should type def something instead of invalid ID U16, right? Nah, I think that's fine. If we need to update it, I'll just go through and update it again. It's not that big of a deal. The only reason I even have these comments is because I already kind of typed them up previously and I didn't really want to lose all that work. So that's the only reason that I'm going through and doing this now. Okay, so this is synchronous. And okay, that's it. So now we actually need to go through and change all of the k-texture pointers, right? So I guess we can do, we'll do k-texture asterisk. I guess we have to do backslash asterisk because this is a regular expression. And we'll just replace that with k-texture globally. And that should take care of pretty much the whole file. We should be good as far as that's concerned. I'm just doing a quick spot check here. Yep. Okay, it all looks good. Okay, so we'll make our entry points for all of that various texture data here in a minute. I kind of want to fix all of these functions first, get our state set up in terms of how we're actually going to arrange this stuff in memory internally, and then go from there. So we'll go here to texture system initialize, and let's see. We do have, what is this bleating about? Type def read definition. Oh, right, because it's still called a k-texture. Okay, so I don't know. We'll call this remove or something. And I guess I'll do the same thing here, just so we don't confuse that with anything else. So essentially what we need is, in order to get this to be a little bit more cache friendly in terms of how we access the data, in particular when we actually have to query for some of this stuff, we are going to store all of this stuff in arrays that are indexed by the k-texture ID that is that U16. So essentially what this means is, in fact, yeah, I guess we'll do... this for now. We'll just copy this and go into the state. And instead of having... Oh, do we even need this assets array, actually? I don't think we do. I don't think we do. I think that can go too. But let's see. Oh, that's for the load. I'm looking at the wrong structure here. Dingus. Okay, so here is the current registered textures array, right? I could do... You know what? Let's actually do this. Let's actually use this structure for something. Let's actually take this, because I don't want to just put a whole bunch of arrays in line here. I think it might be a little bit better organizationally if we do, let's do registered textures, right? And so what we'll have here is, instead of this, we'll have registered textures, right? And then we can say textures dot, you know, handle. Well, no, I don't actually like that. I don't like that. No, heck with it. I'm just going to do it this way, because then I have to do state, textures, blah, 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 all the way down. Okay, so let's do this. And we actually kind of started doing this with the reference counts and the auto releases, right? So we're basically just going to convert everything else to work sort of the same way. I guess what we can do here is we're going to have a K handle pointer, and we're going to say render texture handles. The ID, which is going to just be, let's see, do we have, let me look at this real quick, the texture type. We can't tell by that. What could we use to make this a free slot without actually recreating? We could use pixel format for this, I guess. Yeah, maybe let's do that. Yeah. Okay, so what we're going to say is all registered textures, and then we'll say any of them that have format equals this means that the slot is free, right? I think that makes sense. So we'll have render texture handles. We don't need this ID anymore. We can get rid of that, save a lot of memory there. So we can have types. We can have let's see. I guess so. There's two ways we could do. There's two ways we could do this. Width and height, right? We could store them as separate properties, or we could jam them together as a single property, because more than likely we are always going to want both. Although I guess we could just query one or the other as well. I guess I'll keep them separate for now. We can always change the internal representation of this if we want. So I'll do widths, heights, pixel formats. We'll do flags, array sizes, and then we'll do, I guess, MIP level counts, if I could spell it. There we go. Yeah, I think that makes sense. ST Zaris, I'm not sure what that means. I don't speak Russian. I don't know if that's, I'm going to do a quick Google Translate on that. Means posted. Okay, I don't know what that's all about, but okay. Let's see. Let's see. I've actually got a couple of messages to catch up on here. Painsin, how's it going? Good to see you. MDS Ubuntu redeemed pet on stream. All right. Let me go get my kitty real quick. Give me a second. Let me switch to this. Let go. Let go. There we go. Okay, so this is my older cat, Pumpkin. She does not want to be on camera right now. This is her, though. So she's 14, and her allergies are kicking her butt. I don't know if you can hear her breathing, but she's got some boogies in her nose, I think. But this is her. Yeah, she's about 14, pushing 15. Unfortunately, she's getting kind of older, but yeah. I'm going to put her down before she starts sneezing. Be right back. And before she claws the crap out of my arm. but thank you for that redeem. Let me catch up on chat here. I used map ID texture info, but you're in C, so yeah, I can't do that. Let me see. Question, any reason for it to be handles versus something like a fixed size? Yes, because the size is configurable. So all of these arrays will be configurable as to what their size is. So we have a texture count, which is specified in the config here. Right there. It's actually the only thing you can specify for right now. And the reason we have that, and actually this should be a U16. The reason that we have that is because when we don't necessarily want to set up an array of a fixed size, say 1024, or I know that I'm going to need more than that. So let's say, I don't know, 4096, for example, when I'm only going to use 3,000 of those, and then I'm wasting all of this memory here, right? I don't necessarily want to do that for that reason, right? Because that's what I was talking about before. Like when we actually run the application, we're going to figure out from the actual application itself how big this pool needs to be, and then adjust it to within sort of that range, maybe plus a little bit of padding just to make sure. So we don't want to waste a bunch of memory on this. We also, since this is actually part of the engine, we don't want to hard code the size there and not have the application be able to control it. So that's why. So we could use a free list. I'm not going to use a free list because a free list itself requires a lot of other allocations and a lot of other logic, right? So what I'm actually going to do is we look at a single property to determine whether or not it's considered free. In this case, we're just going to look at the pixel format, and if it's set to unknown format, then we're going to say this particular slot at that index is free, and we use that. In this case, a linear search is going to be much faster when we go to actually look for a new slot. We only are going to have to search once to look for a new slot. We're only going to have to search this array once. So I think linear is plenty fast in terms of when we're starting up. It does not take that long to loop through an array and just check those things. I think at least for now, I'm going to keep it simple, and we're just going to do a linear search on it. And if we need something bigger and better down the road, we can change that very easily. And we can put a free list in here if we need it. I don't think we're going to need it. But yeah, we're going to start off simple with it. You bring up good points, but yeah. Yeah, I'm going the SOA route. Yep, essentially. Yeah, Kitty. Yep. So, Kitty is giving invigoration +1, motivation +1. Yeah, she does. She's mad at me for picking her up, but she'll get over it in like 5 minutes. I don't know where she went, actually. Privet, it's a greeting. Oh, okay. Did not know that. Is it a big deal? I mean, it's not like a lot of memory. Yeah, I mean, I don't think so. One of the primary reasons for rolling your own engine is to minimize waste like that. Yeah, exactly. Navy how's it going? Good to see you as well. Do you know how well does Vulkan play ball with temporary allocators for synchronization primitives or in general? When you say temporary allocators, what do you mean by that? The only advantage and the reason I have something like handles max texture is I can dump the entire struct to a file and restore. I mean, I suppose I could do that on a release build, right? But like, I don't know. I'm struggling to see a huge advantage or win by doing that. I get it. It probably would be faster to do that, but yeah. It's very minor, yeah. Oh, you're talking about the wasted space is very little realistically. Yeah, I mean, again, that would be something I'd want to profile, probably to get to the bottom of it. In this case, I'm going to keep it simple, right? We're just going to set up these arrays, which we're going to alloc them one right after the other, so they'll actually be next to each other in memory anyway, because of the way that our allocator works. So I'm not too worried about that. I like to do the looped testing like Casey, so I can save a state and set the game to go in a loop repeatedly. My entire game state is flat in memory and no indirections. That's fair enough. You can do that when you're not writing something that's general purpose. But this has to be general purpose. It's got to be a little bit flexible. Now, it's not that general purpose, but yeah, we do have to be able to, it's got to be configurable. That's one of the things that is sort of a requirement for this engine, at least the way that, I'm looking at it. After school over there on the YouTube side, as well as Mark, how's it going? Good to see you both. Thank you for the follow. Appreciate that. All right. So what we are going to do is also, I don't think I want to do a find and replace on the texture pointer in here. I think I want to just replace these things one by one. And the reason for that is I want to, sort of verify what I'm doing as I'm going through and changing this stuff. So let's see. Okay, so this no longer needs to be a pointer. That's the listener context. That's fine. Texture get if exists, texture get new. Those don't need to be pointers. Resources acquire, that doesn't need to be a pointer. All of this stuff can actually just be index based. And lookups of that stuff will be pretty quick. So this is essentially what we are going to do. We're already kind of doing it. And again, I might do things, just to kind of tighten things up a little bit. I might combine things like this, but for right now, let's just go ahead and keep it simple. So I'm temporarily copying these down here. And essentially, we want this, a whole bunch of these, right? And so we're going to want render texture handles. We're going to want types, widths, heights. Yes, I know the types are wrong. We'll fix that in just a second. Flags, array sizes, and we need one more. MIP level counts, okay? So MIP level counts is just going to be a U8. Max texture counts, array sizes is going to be a U16. That's already set. This is going to be K texture flag bits. This is going to be, these are actually both going to be U32. So we'll just change that. This is going to, whoops, did I do the wrong lines there? I did. This should be K pixel format. This needs to be U32. This needs to be U32. And then types needs to be K texture type, right? So the idea here is that we're only going to, and this needs to be K handle. We're only going to query most of these things, sort of on an exception case. So it should be, fairly quick to be able to, to go through and actually query that stuff. Sorry if I keep challenging stuff like this. Mostly trying to learn your thought process. No, that's fair. Ask away. Yeah, no worries. It's this is all about thought process and learning stuff, right? And that includes me sometimes. I learn stuff from you guys all the time as well. So I try to sort of brain dump what my thought process is as I kind of go through this. But sometimes I don't think of something till afterwards either. So, if you have a question, definitely speak up. You're not going to offend me with that. Okay, so we need to go through, and we don't have this sort of ID lookup anymore. What we need to do to invalidate these is the zero state is going to be valid for most things, except formats, right? That's really the only thing that we need to make sure is actually set, right? So instead of that, we're going to have invalid ID U16. And that, incidentally, is what marks a particular texture slot as free, right? So let's see. Let's actually update this to reflect that. So we'll do mark all texture slots as free. Okay. All right. So I think that should be all we need to do for that. Okay. Shut down, of course. Oh, you know what? We have not actually killed any of this stuff. I suppose we don't need to, because if we're shutting down this texture system, we really don't need to go through and do all of this stuff too, but why not? So let's do, let's actually take this and we'll do K free type C array, right? And that wants the block, the type, and the count, right? So we already have this. So what we need to do is change 3 words, I guess it is. And we'll change that to a comma. Right? Yeah, I think that's right. We don't have typed config here, but we can get that in a second. So we'll do this, this one, this one, this one, and that one. Typed config. So we can do essentially we can just get texture system config typed config equals the address of state pointer config. Right, good enough. Again, this is sort of handling something that we don't necessarily have to worry too much about. So I'm not going to worry about it too much. Okay, got that. All right, so we free up all of this memory, and we should be good after that. Okay. So texture acquire. That's obviously going to just return just a texture itself. Actually, I think a lot of these are probably going to wind up just being a change to remove the sort of asterisk here. Well, maybe not. So we need to make sure that texture is not equal to invalid ID. And that's going to have to be invalid ID U16. Okay, so instead of having to do now texture ID, which is another sort of layer of indirection here, now we can just do texture, right? Because that serves as the index into that array. So there we have it. Let's see, resource counts and auto releases. All right, now when we are releasing, let's see, we're going to do texture cleanup, which is actually going to take care of the rest of that for us, so we can actually hit that later when we get to that function. So this is the kind of thing that we're going to do. Lookups are just going to be quick index into that array, and we should be good to go there. Let's see. This is just going to be, removing the asterisk. For like a good portion of it, actually. Let's remove that. And that's going to be the same thing as well. We'll change this even though we haven't actually done that one yet. Let's see. Now, the acquire with options is where actually all of the logic exists. So we're going to have to change that. Shouldn't release check if the format is not invalid ID. We will probably do that. I mean, I guess you're probably right. I was thinking we could do that here. But we should probably, yeah, I guess you raise a good point. That should probably be, we should probably also check state pointer formats is not equal to, what was it? Invalid ID is not what I want. Isn't it? Okay, pixel format. Unknown. Did I actually... I think I actually wrote the wrong thing in a comment up here. Yeah, I did. That should be... that. Which actually we don't even have to set. Because it's 0. So... we don't actually even need to do this. We can actually get rid of that. Okay, so 0 initialized actually kind of helps us in this case. All right. Good call, because I would have missed that otherwise. All right, so ktexture t get if exists. We've got that. And then... if an entry with the name exists, return it. All right, so let's see. This is going to be increment ref. Wait a minute. We can't. This needs to be if the ktexture returned is not equal to invalid ID U16, right? So that's an invalid texture at that point that could be returned from here. So if it's not an invalid texture, then that means it exists. Or if it's not an invalid ID, rather, then that means it exists. So increment the reference count. So T is just going to be our index there, so we can just use T. And then go ahead and make the callback. Otherwise, this is where we're going to have to change up a few things. So we are going to need to do, I think we can just do this, and then we can do formats sub t, right? And then this will end up being types sub t, widths sub t, height sub t, mip level counts sub t. And so this will wind up being the same thing, right? So it'll be state pointer, and then I'll just do the same thing here, and then we'll go back here, and this is going to be flags, but we need sub t. Yeah, that makes sense. Okay. So auto releases, that's just going to be sub t. And then we have state pointer array sizes sub t. Same thing is going to be here. And then this is going to be state pointer array sizes sub t. Now, I would say, though, instead of repeatedly calling this, I guess I'll say array size, right? And then we'll do array size here. Just so that we don't repeatedly have to fetch that. Okay, so that's good. Forgot the texture and the formats in the release check. What did I miss? I'm sure I'm going to miss a couple things like this. Wait, in the release check? Forgot texture of the formats. Oh, in texture release. Did we actually... In here. Oh, you're right. Derp. This is going to be texture. Thank you. Rest of it looks good. Okay. All right. So, we need state pointer formats sub t, state pointer flags sub t. Here we go again with that, and state pointer, so we got that, and then this is going to be state pointer handles sub t. Now we have this t here, so we need to make sure that we need to make sure that this is not equal to invalid ID u16, and then we can do state pointer array sizes sub t. All right, so I think that should cover it there. And then we have to just do, let's see, the async version. No, we did the async version, but now we need to do the sync version. We really need to probably deduplicate some of this code at some point too, but we also need to do this function. Which I guess we'll get to that. Yeah, that's going to be at the bottom, so that should be fine. All right. We'll get to that as we kind of work our way down the file. So this guy is going to be kind of the same deal. So anywhere we do like if t, oh, you know what? Did I catch all of those up here? I feel like I might have missed one. I did. So this should be invalid ID u16. Anywhere I was doing if t, right? All right. So that should be, whoops. I see what happened. Okay. So if it's invalid, then we bleat about it. Wait, no, this is if it exists, so that needs to be not invalid ID. Return t. Okay, that should be fine. This needs to be if t equals invalid ID u16. Then we bleat about it. You know what? I'm just gonna, instead of doing this manually, I'm just gonna copy paste this from here. And I'm going to paste it above here just so I can make sure that I'm not missing or screwing something up. But yeah, it should just be a direct replacement for all of that. Okay. So I guess I could do... I think I can safely do a T array size find and replace. Because that's kind of a common one that's used. So let's do that. So we're going to do T array size. And we're going to replace that with state pointer array sizes sub T globally. Have I bollocksed that? There's some places where that's not going to work, but that's fine. I'll clean those up in a bit. Let's do... So T width, T height. I suppose we could also do that. So let's do width and then widths. Did I get that right? I think I did. Yes. Okay. We'll do the same thing for heights. Oops. Double S there. So it's just going to be height. And then I guess we could do MIP levels as well. So I feel like that's also going to be one that's... I think it's MIP level counts and MIP levels. All right, that knocked out a bunch of them. Okay, so wherever we're doing TID, I feel like there's not that many of those, so I might just do those just manually wherever I find them. Let's see. Are we doing if T anywhere here? No, we got those ones already. So state pointer formats sub T, and then we have flag sub T. Oops. Flag sub T, and then state pointer and state pointer. This is going to be handles sub T for uploading that data, and I think that's going to cover that function. Perfect. Texture resize, this is just going to take that now, and instead of this, we'll have to do T is not equal to valid ID 16. And let's see, state pointer flags sub T. We got those ones already. This is going to be flags sub T as well. State pointer, and then state pointer here, handles sub T. Cypher, I'm not sure what you're trying to say over there. That looks like a bunch of XML. I'm not sure what you're asking. Okay. So this is just going to be to write the data. We need state pointer handles sub T. Cypher, I have no idea what you're talking about. Okay, so texture is default. I don't remember if we actually use this or not, but it's easy enough to fix. So we can do if t equals any of these things. And these checks will still work because these are all IDs as well. So that's good. We have that. That just drops into place. Okay. So this is the asset image loaded async callback. So this is now going to just be an ID. We didn't do this bit, did we? We need to do that. Okay. We still, I guess, have a little bit of stuff to do in here. Not a crazy amount, but we do need to actually handle this. Let's knock this out real quick, actually. So the number of loaded assets is going to be something that we're going to have to store in the context. So that would be here. And since this is out there for the entire life cycle of stuff getting loaded, it's fine for us to store it here. So we can just say, I don't know, a U32 loaded asset count, right? It's just something for us to sort of keep a count there, and it's going to be zeroed out by default. So what we'll do is every time this is called, we are going to do context loaded asset count plus plus. And then what we can do is we can do if context loaded asset count equals, and then we'll do state pointer array sizes sub t. Then we can do all this stuff, right? And we'll probably actually wind up. You know, maybe we can put some output, debug output rather. So we'll say, I don't know, kdebug asset. I guess we'll say required asset loaded count met proceeding to upload to GPU. And that'll just give us a little bit of context in terms of what we're dealing with. I guess we could also say for texture ID, right? And then I'll output that as well. So we could just say T here. And I guess we could say asset count will also output the count here, right? So this is going to be context state pointer, actually, yeah, state pointer array sizes sub t, comma, right? So we'll be a little bit informative about it. We'll just leave that as debug, and then on release builds we won't display that. We'll probably wind up eliminating this line eventually, but let's see. You ever take a look at those bots for merging YouTube and Twitch chats? I think it would be a good idea. I mean, I've thought about it. I just haven't done it. You're not wrong, because it would be nice to have like all of that in one. Like if I could find one that gives me not only all the chats combined, but also all the actions or activity combined, like when somebody subs or follows or something like that, that would be nice. It's starting to kind of get to a point where like maybe keeping it open on two separate monitors is not going to be a good idea. Can I ask you something? Does a 64 gigabyte SD card have 64 gigabytes? Or do system files take up some space? It's always a little bit less than that. And then you also have the concept of gigabytes versus gigabytes, right? So counting by thousands versus counting by 1024, that's always going to throw it off. It's the same with any storage device. It's always going to be a little bit less than it's advertised because of that difference. Wondering how much to leave free? I mean, that's hard to say, right? I don't know what those numbers would be off the top of my head without actually seeing, what is actually available on there. Yeah, they consider 1 equals 1,000, not 1,024. Exactly. That's where the mismatch comes from. Because for some reason, in operating systems, they count by 1,000 instead of 1,024, even though the 1,024 is actually what the device is working with. But yeah. Okay. Where were we? All right, so success. If T is not equal to invalid ID. Invalid ID U16. Then we do a texture cleanup on that. Okay, so that's fine. Here is texture if exists. So this is going to be just that now. And what we're going to do is, let's see, this is going to actually take a look into, let's see, how do we want to do this? So we don't actually want to look at the ID anymore. We actually want to say this is, we want to do state pointer formats sub t. If that is not equal to k pixel format unknown, then we consider that used, right? So what this really is we could actually say, oh, you know what? We actually need to change the way that our lookup tree works, because it's using U32s right now, and it should use U16s. So actually what this should be is T equals that. We get rid of that line. Right? And then we're good. When we go to get a new one, it's going to be kind of the opposite process, right? So we have this. We loop through the max texture count. We take a look for formats sub I, and we say, is that format equal to k pixel format unknown? If it is, we go ahead and use that. So we set T equal to I, right? Simple enough. And then we set the nodes value that we're going to insert into the binary search tree. We just set that U16 to T, right? And actually, I don't even think we need to do this T business at all. We can actually just we can get rid of that. We can get rid of that. And then just set I here. And change this to a U16 there. Which, did we actually change this? We did. Okay. We should probably do the same. I think this is the only place where we actually search it. Okay, so we should be good. So we set the U16 to I, we insert that into the tree. If the texture name lookup hasn't been set, we use that new node as the base of the tree, the root rather, and then we do texture reference counts, sub I is equal to 1, and then we do state pointer render texture handles sub I is equal to invalid handle. And that is simply because we have not uploaded it yet. All we've done is get a new entry out of the cache array, right? So we're going to replace this with I, and then we just return I, and that is the new texture. ID. Now, if the texture cache is full, this is actually going to return invalid ID U16 instead of 0 now, because we're not dealing with pointers anymore. So we have that, and actually, this needs to do the same thing, this function, get if exists, right? So if it does not exist, we return invalid ID, saying it doesn't exist. Okay. Texture resources acquire rather, is just going to be removing a lot of this stuff, right? So this is one of the few functions where we're actually going to have to like do lots of lookups, which is not a huge deal. It's a bit of an exception case, right? But it is what it is. So this is going to be sub t on all of these. It's going to be obviously an S there, S sub t, and then this is also going to be S sub t. If I can hit the right freaking key, that'd be great. State pointer, render texture handles, right? So that is that. And then texture cleanup, the implementation for this guy, is essentially going to say if the t is not equal to invalid ID EU16, then we go ahead and do the thing. So we want to release saying state pointer, render texture handles, sub t, we want to pass the address of that. And then all of these are going to be indexed by t. K0 memory, we don't actually need to do, we can't actually do that anymore. So let's come back to that in a second. So what we actually need to do, and I'm actually going to copy pasta some of this stuff because we can actually, instead of doing this, we don't have ID anymore. We do have state pointer, render texture handles, sub t, is invalid handle. We don't need that. We don't need that. So we need to set types sub t equal to, I guess we could just use 0 for now, right? That's fine. Widths sub t is equal to 0. Heights sub t is equal to 0. This is an important one, right? So formats sub t equals k pixel format unknown. Oops, forgot the equals. This marks the slot as free. MIP level counts equals 0. Array size is 0. Flags is 0. Oops. Bollocks that up there. We don't need this one, actually. And these need to be semicolons, not commas. Okay. So, did I get everything? I think I did. Handles, types, widths, heights, formats, flags, array sizes, MIP level counts. Yeah, I think we have everything here. Okay. So, you know, we don't have just a contiguous block of memory with all these properties in it, which is fine. So we do have to, you know, look up into these arrays, but that is just fine for what we're doing here. Okay. So, combined pixel data is the next one we need to do. What has happened here? One of my find and replaces did something funky. Okay, so what this is doing is, let's see, widths t, expected width. Oh, this is supposed to be, I see what happened here, actually. So this should be asset. This should be assets. Oh, interesting. Okay. Whoops. width. I guess one of my find and replaces was a little bit too zealous there. So this is going to be I. Let's just go ahead and replace this one too. And then this is going to be... That is one of the reasons you have to be careful with find and replace, right? Because sometimes it can actually bollocks you in other ways. So 1 GB free should be fine, or leave more. You don't have to leave anything free, technically. If you're talking about an SD card, like, you don't need to leave any free space on it, theoretically. Just put stuff on it until it runs out of space, essentially. It's not like a system hard drive where you have to leave a little space on it for, paging and the OS to use for, things like paging. If it's just an SD card, don't worry about it. If you're asking what I think you are. All right, so apply asset data. This is basically the upload of the data, the texture data. So this needs to, again, be state pointer for these guys. Right, and then it needs to be flags sub t. So flags sub t, and then formats sub t. And then this is going to be state pointer render texture handles sub t. And cool, we only have 1 error left in the file. Awesome. Well, 1 error and 1 warning. I'm assuming the warning is probably, yep, we don't need that anymore. Now, what is this complaining about? K-resource utils. K-resources, K-resource utils file not found. Don't we have that? That's going to be... Oh, I guess I removed it. I don't think we actually needed it. I think that's why. All right, so I think we can remove that. Render or front end, though? Okay, so the renderer is also going to need some updates here. That is actually not too surprising. So renderer types is going to have some problems in it because of the K-resource texture. So that's just some fallout from some other stuff that we've done elsewhere. So let's, I guess, look at that one first. Thank you for the follow, by the way. Go to, why is that being checked? Did I miss something? Did a find and replace get me? I'm not sure, LaFolie, what you were talking about. Oh, the automod thing. I gotcha. Of course, the first message that Sulfoam types to also gets automodded. Pretty jealous of your glasses. I wear contacts, but today I had to tell a coworker I use Arch at home, and I had no glasses to push up as I told him. Saddening. Yeah, and these things are, well, I mean, I can't actually, I don't know if you guys can see that. I'll try to hold it up, but I'm so freaking blind. Like, those are Coke bottles, you know? They're pretty thick. These are the lightest weight lenses that you can actually get, and they're still pretty thick. They're what I would consider 2C thick. So yeah, proper Arch user. Blind. let's see. So what was that talking about? Let me scroll back in chat real quick. Imagine if CXX gets defer. Can already make one, but the interface will be different for MSVC and GCC. Yeah, because you have to use extensions for that, essentially. Which is why I'm not doing that. Let's see. Thomas Ray over there on the YouTube side. How's it going? Are you utilizing Vulkan bindless rendering? And are you using deferred or forward rendering? So we're not doing bindless at the moment. Because bindless is not actually supported in all hardware setups, and I'm trying to target a reasonable amount of hardware. So I'm not doing bindless, and I don't really have a need for it, frankly, at the moment. Am I using deferred or forward? So right now we're doing forward rendering. I do have deferred on my to-do list, and I will implement it in this if the game we need, or if the game that we're developing needs it, which I suspect it might in the future. But for right now, no, not so much. I'm in the process of a long refactoring process of my rendering engine. Starting to get lost in my code base. Ouch, that hurts. Are you trying to replace the camera lenses on the Voyager spacecraft? Yeah, I know, right? Yeah. Yeah, these are pretty thick. You should see my sunglasses. They're actually worse, but they're all the way at the other end of the house, so I'm not going to grab them. But yeah, because sunglasses are like also like taller, they're super heavy, so I can only wear them for like 30 minutes at a time before it like actually hurts my nose because of the weight of the lenses. I'm also blind, so I can't judge you. Yeah, exactly. Basically, when I go to get my prescription updated, you know, the prescription just has LOL written on it. Hop over to Twitch. Okay, yeah, I mean, yeah, I do watch both chats, so, but sometimes when I'm programming, it takes me a couple minutes to actually check them, so I do watch on both sides. But yeah, I am simulcasting to both. Alright, so, what was I doing? I think we were talking about the rendering front end and then renderer types, which is, oh, the material system, right. So I'm not going to be able to refactor this and just do the texture system. I'm going to have to touch the material system too. And technically anything else, any other system that requires textures, which I guess we kind of knew. But I wasn't thinking it was going to be a big deal at the header file level, but apparently it is. So let's see. We don't need resource types on that. Okay, so we have material texture get, which I think is material texture get and material texture set, and then we have shadow map texture and irradiance cube map textures. Okay. So I guess I could fix this at this level. And just use these. Okay, resource types. We need that again. Okay. Thank you for the follow. I appreciate that. Let's see. And then I'll just fix these two spots. And make those not pointers. Let's see. I think that's everything I'm going to need to do, because they're just textures are just a number now, so we don't need pointers all over the place. Okay. You know, this is actually kind of foobar now that I think about it. Why do we actually have material system in our renderer types H? That should not be there. I'm going to delete that. And we will work around it. Okay, so K-window renderer state. So this is just going to be a simple thing also of removing those, just converting those types. Render types. Okay, so this is the renderer backend interface. So this just needs to be converted to use K texture flag bits because we changed the names of those types so that we can actually see where those changes are made across the code base. So we just need to add a K in front of those. Okay, that might actually be it for this file. Yep, okay. So let's go back to texture system. Unknown texture type. What did we miss? Did we miss? Yeah, we missed a couple in here. So this should be K texture type. This should be K texture flag bits. And then same thing here. And that is it for the renderer front end. Obviously, the implementation of the renderer front end is going to need some work, but I think that should actually do it. All right, I'm going to try and build this. I know it's going to be full of errors, but it'll at least kind of let us know the next place we should look. Okay, so it looks like our bitmap font handler is going to be probably the next thing we need to fix so that we can actually compile. Which makes sense because that actually uses the old asset request system to get images and ultimately textures. So that is going to be what we'll do next. So let's see, the K resource handler. It's the resource handler, right? Not any of the asset handler. Yeah. This resource handler is eventually going to be going away too. Bitmap font. So I guess we can start with the header file. I don't think there's anything in here though that we need. K resource handler bitmap font C. And let's just go through and fix the errors. So asset system, I don't think we actually need. I think we can actually get rid of that. Because we're going to get rid of all of these, all this request stuff. And we're actually just going to request textures synchronously from the texture system. So most of the time when we're requesting a texture for something, we're going to want to do that asynchronously. But I think for the purpose of fonts, which is something that we're only ever going to load once, and probably at the very beginning, I think it's acceptable to just use the synchronous version. It's going to simplify our code. We don't have to worry about callbacks or loading or any of that stuff. So I think it's perfectly reasonable to say to use the synchronous texture system request. So that means that we can get rid of a whole lot of other stuff too. Bitmap font K asset on results. So let's see what this guy is actually doing. So if I remember correctly, there are two aspects to this. We actually have the K asset bitmap font itself. And then we actually have the texture associated with that. So all we're going to do right now is the texture portion of this. And then we'll convert the rest of this over later. So asset request info, that doesn't exist anymore. Let's see. Type asset info type. Oh. We might, though, we might actually have to... We might not be able to avoid doing this because we actually need to load up the bitmap font asset, right? So there's two there's two things here. I guess I'll show an example of what the assets actually look like, and we'll go from there. So actually in here, and I think I put them in the standard UI, I believe. Nope, maybe it's in runtime. Yep, here we go. So just move this over for a second. So we have a few different things here, right? So we have these KBF files. So these KBF files, these KBF files are sort of binary font files, and then the KSF files are like a font configuration file for system fonts, right? And then we also have these TTC and TTF files, which is what is used by the system font. So these KBFs are actually, I didn't think I made a binary format for that, but I must have. So what this actually is, and you can actually kind of see the data in here a little bit. So this is all of the glyph information, all of the kerning information for a bitmap font, right, as we have imported it, right? So whenever we import a bitmap font, we actually include all of that glyph and kerning data and, you know, things like spacing and whatnot. All of that stuff is included in this file. And actually, I even think, yeah, we actually have the name here too of the texture that we use, right? So we can actually, we read this whole thing as a binary blob so that we don't have to sort of decode what all of the glyphs are and everything. And then we go ahead and we request the texture after we read this in. So essentially what happens here is we actually need to request the bitmap font binary file, and from that we can extract the texture name or the name of the texture image asset that we need to request. So the problem with this is we don't actually have a way to request this now, right? Because we changed up our asset system to require us to sort of load that via a very specific API. So this whole generic request system doesn't exist anymore. So unfortunately, I think that means that we're going to have to write the functions to request a bitmap font from the asset system now as opposed to later. I didn't really want to do that, but I guess it's, you know, it's kind of forced my hand, ripping off the Band-Aid, as it were. So what I mean by that is in the actual asset system, we have a set of functions for each type of asset, right? So loading up a binary asset is done this way. Loading up an image asset is done this way. And as we can proceed through all of the other asset types, this is kind of the way that it's going to work. And so this greatly simplifies our API, because all we have to do is provide, like to request an image, we provide, you know, the system state and a name, and flip Y, which is probably going to go away, and then a listener and a callback for the asynchronous version. And then we only need the state, name, and flip Y for the synchronous version. For something similar like a binary, all we have to do is provide a name, right? And obviously a pointer to the state. So the idea here is that instead of filling out something like this every single time we need to request something, we just make a single function call with a few parameters and we're done. Don't forget to make macros for your macros. Yeah, I know, right? Sakelos Music, how's it going? Good to see you. Don't forget to make double macros for your macros. Yeah. Yeah, I mean, you know, we have a fair share of macros in the system for sure. Let's see. When the ophthalmologist labels your patient file as bat. Yeah. You're talking about, like, you would wind up having batch files like what we have here for Windows. Okay. I really didn't want to do this now, but I guess let's go ahead and do it. So we need to request a... Let's see. Let's go look at this, because I think it's just a K-asset bitmap font, if I recall correctly. Yes. So we basically need to make one of these. All right. So we'll go down here to the bottom. Paste that real quick. And essentially, I think I can actually just kind of copy the way that this guy is done. It's basically going to wind up being the same. So let's put this in here. And this is going to be bitmap font assets, right? And then this is going to be K-asset. You know what? Let's just do that. Let's just replace the whole word. And do that. And we'll do bitmap font loaded callback. And then this is going to be just going to be that, right? So we have that. And then release bitmap font, which also needs to be bitmap font. Okay, so as far as the functions go, we have just a simple request from the application package, and then an asynchronous request from the application package, and then loading a request to load from a specific package, and then an asynchronous version of that, right? So we have the sync and async versions. I actually don't think for this type I'm going to support asynchronous loading of these. I don't think it's needed, and I think I think we should always just do it synchronously, right? Because we're not going to be loading that many fonts, and when we do, it's only going to be like on startup. We're not going to be like loading them in the middle of actually like running the game. So I think it's perfectly acceptable for us to say, you know what, let's just simplify this and not do asynchronous loading for this, which also eliminates the need for that, right? So realistically, we just have two different functions here. One from the application package, and then one where you specify the package. I have 6.1k coffees. If I spend them all on hydration, I could kill you. I guess you could, yeah. Thank you for the hydrate redeem, by the way. So if someone wanted to mod fonts into the game, they would have to restart. So, and that's what I'm kind of trying to think through, right? Well, no. If they wanted to load a font right through the font system, they could do that. And when we get to the font system updates, you'll see what I'm talking about. So whenever we say that we're going to load up a font, that process is going to be synchronous, period, instead of asynchronous. Because we really, in order to load a font and have it be immediately usable, which is generally what we're going to want, we need to wait until everything is actually loaded, which is not going to be all that long, because for a bitmap font, it's realistically, you're talking about that binary file that we looked at that has all of the, the kernings and the glyphs and all that stuff, all that data. And then a single texture file, and that's it. So you could do that realistically at any point in the game, right? I don't think that's the best idea, but this is bitmap fonts we're talking about here. System fonts may wind up being a separate thing, but system fonts also work completely different, right? So a bitmap font is a fixed size of a font. Like you're not going to have, I don't even think you're going to have a ton of them, right? You're generally only going to have, probably one or two, and it's going to be a super specialized font that you would use. System fonts are probably going to be way more widely used, and that's going to load those true type fonts and use those instead of a texture to render it. So whenever we request from the font system, hey, I want to use this font, that process will be synchronous. So if you do it if you wait, so for example, let's say you wait to load a font until you actually have a UI element that uses it, for example, right? So let's say you want to open the inventory window and it uses some special font, right? Or I guess inventory window is probably a bad example. Quest text or something like that, right? So you open a window that has quest text on it and you wanted to use some sort of specific font. See you later, Nibby-me. Have a good one. If you wanted to lazy load that, then you might get a frame hiccup the first time you actually load it. But then after that, you wouldn't, right? So you could do it that way, or you just preload all the fonts ahead of time, which you're generally going to know in the game which fonts you want to use, and then you're good. That's basically what I'm talking about. My monthly subscription of Monster has given me over time a high enough caffeine tolerance to kill a bear. I understand. I used to drink that stuff a lot until it started causing gut problems. So I can't do the energy drinks so much anymore. All right, so I guess let's go ahead and implement. Let's go ahead and implement these guys. Did we also, I think we also put that big honkin' comment in here just to kind of visually split it up inside of this file. It's not something I normally do, but since we're going to be handling all of our asset types in here, I'm going to do it. So we don't need the export stuff here. All right, so when we go to process a bitmap font, we can actually probably realistically base this off of the logic up here that we have. Let's see. Probably want the synchronous version of it. Right, we could probably base everything off of this, right? And then just tune it to what we need. So I'm going to do the package version. And then essentially the non-package version is going to pass a 0 in to the package version of the function. So we'll do return asset system request bitmap font from package sync, right? And we'll do state package name. Let's see. So package name is going to be 0. And then we'll pass through name. Right. And then I think that's what we did, right? We passed a 0 up here, I believe. Let me just double check that real quick. Oh, no, it's this. My bad. I knew that didn't seem right. We want to use the application package name string, right? So basically what we're doing here is if we don't provide the package name, then we're using the default application package to load that up. All right. So this check is good. The out asset needs to be bitmap font out asset. We need to allocate that type. Whoops. And then VFS request info is probably going to wind up being the same, I think. Yep, okay. We request the asset sync. And this is going to be where things vary a little bit. So instead of just performing instead of just performing a copy like this, we are actually going to, let's examine the structure, because I think there's some other stuff in here we need to get rid of, such as the base. We're not doing that anymore. So we need face, size, line height, baseline, atlas, size, X and Y, glyphs, kernings, and pages. This is all of the data that is sort of binary serialized to that file. So we essentially need to load all that in binary, right? From binary. Did we actually have... Let me go to K-asset handler, bitmap font binary. I think this is going to be the one I want to use. We do have a serialize here, so we actually want the deserialize. So we want this guy. Okay. So essentially, we just need to perform all of these operations in here. And then we can actually get rid of or not use this. I wonder actually... I think we kept the serializer for images, but we just kind of renamed it or refactored it to take the actual explicit asset type. And then removed this, or deleted the asset handler. I think that's how we did it for image. Yeah, K-asset image deserialize. There it is. So we probably want to follow this pattern from here down. In fact, let's take this, and instead of doing, did we do size? Yeah. Instead of doing this, we'll do that, and then we'll say K-asset bitmap font deserialize. So we'll need to take this guy, and this will need to be, instead of just a K-asset, it'll need to be K-asset bitmap font. And then this here needs to be, the same thing. And then over here, we can make this change here, and then down here, we can make this change here. So we're changing this from being quite so generic to being specific to the type, so we don't have to do all this casting business and trying to figure out how we should cast it and is it correct and all that other stuff. So we're going to worry about the deserialize one first to get that kind of up and running. So I guess we don't have, I thought we had the serializer. Thank you for the follow. Appreciate that. This needs to be bitmap font serializer. Okay, so we passed that. We get out asset. So at this point, this is good. This just needs to be bitmap font asset. This needs to be bitmap font. And we should have everything at this level that we need. Yes. Okay. So at this level, it's pretty simplistic, right? All of the actual heavy lifting in terms of actually reading the binary file is done here. So let's see. Do we do? I don't think we have a version. I'm going to comment this out because I don't think we need it, but I'll put it to do anyways. We don't need the asset type because we know specifically what the asset type is, so we don't need to do that anymore. And actually, that might be all that we have to do. And I suspect it's going to be something very similar here as well. So header base type, it's asset type. This is going to be So I guess we'll do, when we serialize this, we'll do k asset type bitmap font. We'll just hard code it, which I think is fine. Bitmap font serialize. So this is the type of type checking that we don't have to do anymore because we know we're being passed the bitmap font asset here to serialize to disk. So we don't need to do this. And that actually fixes this. Perfect. Okay, so Loaded Guns, thank you so much for the Prime subscription. I really appreciate that support. Thank you very much. That really means a lot. It'll go a long way to helping me fund this project once we go into game development full bore. We're kind of bouncing back and forth right now, but yeah, thank you so much for that support. I really appreciate it. Jeep, thank you so much for the gifted subs. Thank you very much for the 5 gifted community subs. I really appreciate that. You kicked off a hype train too. Thank you guys for that support. I really, really appreciate that. Sorry I don't chat much. That's no big deal. Like chill and listen. Wish I had a fraction of your skill. Yeah, I mean, I appreciate the kind words. You know, I think all of us feel that way about somebody. You know, I wish I had a fraction of Carmack's skill. You know, John Carmack. But yeah, no, I really do appreciate that support. So thank you very much. And Jeet, thank you so much for that as well. If you guys did happen to get a sub, feel free to tell Jeet thank you for that. Yeah, cool. So yeah, thank you for that. Much appreciated. All right, releasing the bitmap font. So I don't actually, did we do that in here? I don't think we did. We have deserialize and serialize here, but we didn't actually free any of this stuff. So I think all we actually have to do when we do deserialize, let's see, are there any? I think other than the glyphs in the kernings. Let's see. This is... Actually, do we even do... Yeah, okay, we use this type... Oh, you know what? I'm very tempted to get rid of that type because I don't actually like the way that this sort of came out. I'm going to put a pin in that. I'll come back to it. So for the bitmap font, obviously we need if state and font asset. Okay. So when we go to release this guy, if the only thing I think we actually have to do is glyphs and kernings, also pages. So glyphs, kernings, and pages if they exist. So I guess we could do let's do array, kasset, bitmap, font. Let's do kerning, destroy. Singy, thank you for the membership over there on the YouTube side. Much appreciated. I really appreciate that support. Thank you. So we need assets, kernings. Do I need the address of that? Probably. Yes. Okay. I don't remember if this does a check. When we destroy. Yeah, we do. Oh, we don't actually check to see if this actually has. You know what? Let's. So we don't actually check to see if we need to free this. Actually, maybe we do. Do we check that in here? I wrote this code a while ago, so I just have to double check. Okay, this does do a check to see if the block exists. Okay, all right, so we should be good. What I was trying to get to the bottom of was, do I need to check the internals of this to see if this actually exists? But thankfully, this is smart enough to actually do that on its own. I wish I had a fraction of Linus email typing skills. Yeah, Linus's emails are fire. For sure. For sure. I'm trying to remember what was the name of the guy that he was flaming so hard that one time. The one that's kind of become a meme that circulated around. Let me see. Marius, I think it was. Yeah, I think it was Marius. Wish I had the info copied from Sacha Williams' brain. Yeah. You and I both. Used to envy the skill of this one dev at work, but then he got forced into management and is now rotting there. Ooh. Yeah, that's always a weird thing. I've always felt like, whoops, that is not what I meant to do. Well, I accidentally pinned your message because I was trying to click something else. There we go, unpinned. So I've always thought that career path was a little bit weird because it's like you're supposed to step up to like junior, from junior dev or sometimes intern, junior dev, mid-level dev, senior dev, maybe like architect or something like that. And then they put you in management, right? And to me, that's always been a weird step because it's like the skills having to do with like people managing have nothing to do with development whatsoever. I've always found that extremely weird as a career path. So yeah, I don't know. That's just never made much sense to me. Mess with the multi-channel SDF fonts instead of regular bitmap. It's a whole lot more lenient as far as scaling and not getting too much aliasing. Yeah, so sign distance field fonts are something I have planned for the future. But for right now, our system fonts are going to have to handle it. Between bitmap fonts and system fonts, it gives us most of what we need. But yeah, SDF is the way to the future. Eventually, we're going to put that in this engine as well. It's not too hard to implement. I just haven't gotten around to it. Thought it would be expensive performance-wise, but it really isn't. The cost is during generation. So offline stuff. That's true. Linus is representing average conversation in Finnish culture. That's awesome. And hilarious. I'm a lead vehicle artist, and I can say it's an interesting in-between as management, but also have a hand in art, but control over a bit of the development process and get to manage and maintain the look of the game in regards to vehicles. Yeah, so that does make sense. Like I've held lead developer positions before, and that's kind of like a management light kind of thing where you have like developers under you. That I guess kind of makes a little bit of sense, but like going to full on management doesn't make sense to me. You know, like I feel like a lead artist or a lead developer, like you're still actually in there writing code, but you also have people underneath of you. If I'm a programmer, I don't want to do management. I just want to write code, and that is what I've done. Right, like that's where I'm at. Because I've done the lead dev thing, I've done the management thing. No thanks. I don't want to do that. I just want to write code. I agree. All right. So we need to do glyphs and pages. And so we need bitmap font page, and then glyph destroy. All right. So that is all that's actually going to be required. I suppose we could also do a K0 memory, right, on the asset, and then do size of K asset bitmap font, just for good measure. But that's really all that's going to be required to release a bitmap font asset. So that wasn't actually as bad as I was thinking it might be. So let's go back to, let's see, where were we again? The bitmap font resource handler. Okay, so instead of doing all of this crap now, now what we can actually do is we can convert this to just a synchronous call to the asset system to get the asset that we need. So pretty much typed requests. Okay. We are going to have to actually rework this a little bit. Well, okay. So we have the request for the resource, which is the bitmap font resource. We eventually want to get rid of that and just have it be a bitmap font. But I don't really want to do that as part of this change. I kind of want to just get this thing working the way that we need it to work. So what I think I might do is actually just kind of ignore the info that's passed in, other than the name, I guess, of the asset. Let me see. K-resource asset info. I suppose what we could do is we could do assets, asset system request bitmap font. Engine systems gets asset system, asset state rather. Oh, that's release. I did the wrong one. Bitmap font. We want request bitmap font sync is actually what I wanted. And then the name, we can do info, assets, base, or actually data, Sub-0. We'll just do asset name, and then we'll use the from package version, right? So we'll do info, assets, data, Sub-0, Sub-0, package name. And then we should, at that point, have a K asset bitmap font. right there. So instead of having to do all this poop down here, this basically goes away. And we can call bitmap font KAsset on results, which I think we can simplify this. Because this then calls assets resource if this is a success. So I think we can definitely work around some of this stuff. Let me see. Thank you for the sub over on the YouTube side. Appreciate that. Welcome. Let's see. Lead dev is like 70% meetings, 30% coding. Depending on where you are, that can be true. Yes, at least in Corpo. Yep. That's probably true. And you have to basically talk about all of the, make all the design decisions, and then, make non-technical people try to understand it. That's mostly what that job is. And then try and, be the liaison between that and your actual devs and try to translate all of that. The way I see it, lead coder should be in the trenches fighting against the regime of bugs. Yeah, that's true. And depending on the requirements, sometimes that could be true. Rudimbo with a raiding party of 21. Thank you so much for the raid. What did you get up to on stream? I don't believe I'm following you, but I'm going to right now. Thank you very much for the raid. Welcome, raiders. I'm going to give a shout out to Rudimbo. There we go. So what did you get up to on your stream? What were you up to? Let's see. I'm going to get, while I wait for your answer, I'll pull this down so that your folks can understand what we're doing here. Doing a game engine for browsers. Okay, that's really cool. So we are also making a game engine. Yeah, I'm definitely going to be checking out your stream next time I see you online. Yeah, what we're doing here is we're building something called the Kohi game engine. And so it is built using C and Vulkan as our initial rendering backend. So it's built completely from scratch. We avoid use of libraries except in a couple small scenarios, which I'll get to in a second. But we pretty much do everything from scratch. This started off as like a YouTube tutorial series on how to build a game engine, but game engines are huge things, right? You can only get so far in tutorial series. So we've adopted different formats and tried different things over the years and ultimately landed on this live stream format, and that's what we're doing here. And so this is designed to be sort of an educational series on a way to build a game engine. It's not the only way to build a game engine. It's not even necessarily always the right way to build a game engine. But we try a lot of different things on here. We experiment with things. Sometimes we purposely do things the wrong way to expose why it's the wrong way. And we'll do a deep dive on some of those things. The idea is that by stepping through all of this stuff live, folks can kind of get an insight into the thought processes and stuff that goes into developing a game engine. We do simulcast to YouTube and Twitch. So the website we're looking at right here is, I'll drop that in here into chat. This is sort of the central hub for the project. It's got links to our channels here, a Discord server, which has got about 1,000 people on it, GitHub and Patreon. I don't have any sponsors or anything other than you guys, right? So that's why that's there. I also have a link to the GitHub. So this is free and open source. It is Apache 2.0 license, which means you can use it for whatever you want, whether it's personal or commercial. It does not matter. All that I ask is that you say that you use it if you do. There will never be any sort of licensing or royalty fees whatsoever. This is designed to be an educational resource. I believe this stuff should be free, so I will never paywall any of it. That is for the engine itself. As for the games I build with it, I might keep those closed source until the game is released. But as far as the engine itself is concerned, that will always wind up being open source. So currently we have and I can't actually demo it, unfortunately. We do have a basic PBR pipeline in place with cascading shadow maps and various different types of lighting. So here you can see a couple of screenshots with some examples. These are kind of dated at this point. It actually looks a little bit better than this now. We actually have a water plane as well. But everything, including everything that you see on here on the screen, we've developed from scratch. So we have a scene that's capable of moving objects around and transforming them, rotating them, scaling them. We have a bitmap text. We have a UI system that supports bitmap text, as well as what I call system text, which is true type fonts, including UTF-8. All that stuff was built from scratch. The only exceptions to the from scratch rule is we use STB image to load, or I should say import, various different types of image formats and when I say import, we convert those to our own custom format. And then we also use STB TrueType to load the TrueType fonts, but we also convert that to our own custom format as well. So those libraries aren't used in the runtime. They're used, essentially they'll be used by the editor or external tools to import. And so this is a little bit more about the project here. It's still pretty early days. We're actually just kicking off our first game project with this. And so as a result, we kind of go back and forth between gameplay code and engine code. Because this is a brand new engine, we're going to find things that need to be fixed along the way. So sorry for the flashbang. Let me just do that. So the game that we're creating is called Shadows of Illumina. It is a 3D isometric action RPG. We've got a rather large document here, 29 pages long so far, of lore, a little bit of world building, all the features we want to build in. We're constantly expanding this. So that's kind of what we're doing here. That's the short version of it. All right. Let's see. You're doing the same no libs, awesome, but in JavaScript, sweet. I made a kind of the beginnings of a TypeScript game engine back in 2018 on my channel. If I were to redo it now, it would be in JavaScript as well. But yeah, that's really cool. I'll have to definitely check that out. Let's see. I wonder how Valve handles that since they use flat organization. So I can speak to the whole flat organization thing because the studio that I was a part of claimed that they were a flat organization too. But yeah, responsibility doesn't really work that way. So essentially what being a lead means is that you get a bunch of extra responsibility and you're responsible for the actions of people, but you don't really have the power to do too much about it because only the higher up execs can make decisions about things. So it's kind of not a great role. But yeah. Let's see. So like I mentioned, we use Vulkan for our rendering backend, and then we actually have right now we're using OpenAL as our audio backend because we do support. I forgot to mention we do support Windows, Linux, and Mac OS. So we are cross-platform as well. And so OpenAL made the most sense for that. We are also going to have Fmod support because that's kind of an industry standard. But yeah, I'm not going to write all that stuff from scratch because that doesn't really make sense. Linux has like a bunch of different sound systems. Windows has got 3, Mac OS has got 2. It just doesn't make sense to support all of those things, right? As far as the actual OS platform layer, though, we did all that stuff from scratch, right? So we use the Win32 API. On Linux, we use X11 right now with Wayland support planned for the future. And then, of course, on Mac OS, we keep that native as well. TypeScript is what I'm learning at the moment. Working on a browser text-based RPG game using ASCII art to give it some feel. using it as a project to grow my skills as I progress through school. Working on a bachelor in computer science, went with TypeScript to catch errors before runtime. That's awesome. That's a great project to do that with. So yeah, good on you for that. My audio backend is using ALSA, Pipewire on Linux, and WAS API on Windows. Yeah, I didn't feel like doing all that. That was another section where I was like, well, if I want hardware, support for audio and not just, have to like re-implement it on a bunch of different systems. Like, I don't do that for graphics. I don't think it makes sense to do on audio. That's a solved problem. It does not make sense to build that from scratch. LaFoley, you haven't done audio in your engine yet? Yeah. It really wasn't that bad, if I'm honest. So the back end for OpenAL, which is what essentially is what makes all of those calls. The whole file is under 1,000 lines, just under 1,000 lines of code. So it's really not that bad. It's good enough as a start. Like, it gives you spatial audio, lots of control. It's pretty good. Probably gonna go with MIDI audio. Never used it, so I can't talk about it. But OpenAL is also pretty widely supported as well. So I don't need any super fancy audio processing, but it's pretty powerful actually. So yeah, I like it. It's worked out pretty well for us so far. All right. By the way, it seems like the Wayland Vulkan grievances I have can be solved essentially by writing your own swap chain with Wayland. That sounds kind of like a gross thing to have to do. There's got to be an easier way than that. Gotta be. How does X Wayland do it? That would be my question. If I had the patience to deal with audio sync issues, I would write an audio library for myself. Yeah, fair enough. Wayland custom swap chain, hearing that makes me want to puke. Yeah, I'm there with you. Do not have time for that. I don't have time in my lifetime to learn all that. Yeah. Yeah, exactly. I'm going to be 40 this year, so I hear you. Allocate images with hardware, memory descriptors, attach them to Wayland buffers, and then commit them to the surface. It seems then you can synchronize the buffers. Okay. That doesn't sound terrible, but dealing with my own graphics swap chain and pipeline system makes me want to cry already. Yeah, it's bad enough to have to do it in Vulkan, but then to have to do it at the Wayland level, yeah, it's a big bunch of nope. Not going to be doing that anytime soon. Like I said, it's on my to-do list, but my other platform layers are stable. X Wayland works just fine. So, yeah, I'm just going to stick with that for the time being. All right, so what we were talking about is essentially we have this check to see if the asset load was a success. We can bypass that, right? So let's actually just do this. Get rid of this bit, right? And then we can take this. We have this asset to resource, which, let's see, that's called from one place. Yeah, so we can actually do, we can take this code and put it up here. Thank you for the follow. FIFO mailbox equals synchronization error almost instantly, immediate mode sooner or later. Oof. That sounds gross. I do not want to do that. That sounds terrible. Alright, so how do we want to handle So out bitmap font is listener typed resource. Let's take this. Let's take all of this stuff, actually. And we're going to put it here. And then we'll just say kasset bitmap font out bitmap font equals listener typed resource. Why is this bleating? Oh, because it's a resource. Crap. Okay. That's what we need. And then asset. Why does that not have... struct kasset? Because this needs to be that. Okay. All right, so we can get rid of this. We can get rid of that. And then let's take this function. Let's actually fix this real quick. Let's take this function and we will move it here. So we can do, how do I want to do this? I guess I can copy all of this, right? Because we don't need the asynchronous bits. So we can literally take this think about this for a second. Paste. Okay. So the asset is here. We don't need this listener stuff anymore. So we can actually eliminate this structure. We can eliminate this function. We don't need that anymore. And then we don't need listener. We don't need this. We don't need that call. Typed resource, actually. Where was typed resource? That's the only thing I do need, actually. Oh, it's literally just typed resource now. Okay. So actually, we could just get rid of that. I wonder if I can just do... No, it's not going to let me do that. I'm not surprised. Okay. Let me finish converting this. So destroy the request. That's the listener. Request info. So this is actually going to be info. So this is actually just going to be array key resource info. Wait a minute. Is this request info? Yeah, there's no base. Okay. That's what it is. So info assets, and we probably don't need parameter incompatible. Asset info destroy. Isn't that what? Oh. No, is that not it? Let's see. Swap chain otherwise works fine on XCB. It's only on Wayland I keep getting the swap chain desynced. That is a good point though that Diamond brings up. You might have that set up wrong. And maybe you're just getting away with it in XCB. Let's see. Question. In a simple triangle, only my VKQ present KHR blocks on call and takes like 250. I always thought that it is a no-op and the block would happen at the fence. Do you know why that might happen? Wait, you thought what was a no-op? The presentation? Is that a blocking call? I'm trying to remember if it's a blocking call or not. I don't think it should be. For context, at the wait at the fence is only like 20 microseconds, and the rest of the application is like 50 on mailbox mode. I thought when you called Q present, it wasn't a blocking call. I don't think it is. I don't think it is a blocking call, but that doesn't mean it doesn't take forever, if that makes sense. I don't know how the dispatch works under the hood, though. I've not actually profiled that, so I actually have not looked at how long that actually takes, but I don't think it is a blocking call. So like if the presentation takes like a really long time for some reason to actually complete, that may still be different than the internal, getting to the point of the actual dispatch happening internally, if that makes sense. So just the overhead of the actual, like, setting up the dispatch for that to actually happen sort of asynchronously is 3,500 FPS reasonable for just a triangle? Probably, yeah. Trying to gauge if I messed something up. It doesn't sound like it, because, like, well, I mean, what GPU are you using? Because even a 3090, okay. Because I have a 2080 Super, and the highest I ever saw, I want to say, was like 1900 frames a second or something like that, with just like a single triangle. So I don't think you've messed something up. I think that sounds about right. I don't know. That seems roughly correct to me. It's hard to, again, it's hard to say without like profiling it, but like, as far as I know, presentation is never a blocking call. But that doesn't mean that the actual creating the dispatch under the hood doesn't take some time. If that makes sense. I think you've got it right, because that's not like a ton of time. Bright Programmer over on the YouTube side, how are you doing? I am doing well, thank you for asking. How are you? Let's see. What does this want? K-resource asset info array. And this is a K-resource asset info. That should be Why is that complaining? Oh, because it's const. Right. I guess it shouldn't actually, this probably shouldn't actually be const because of this, but this is only temporary, so I'm just gonna, you know what? I'm just gonna cast the const away. I know that's a quote-unquote bad thing, right? But like, we're gonna be getting rid of this anyway, so I'm not really worried about it. Okay, so request info. Listener request info. Okay, this is the listener itself. We don't need that anymore. So all we need is this. Okay, and then this has some sort of error. Oh, right, because these are k-names. And we no longer deal with k-names at this level, so we're going to have to translate this until we rewrite it. So k-name string gets and k-name string gets. Okay. So that's now all sort of rolled into one function. That's a lot easier to deal with, and it's another thing ported over. Wait a minute, I missed something. Typed request. Oh, it's unused. Okay. Okay, that makes sense. All right, resource handler, system fonts. Okay, so system fonts are going to wind up being the same thing. So, okay, so this is actually fallout from us redoing the asset system. So we're going to basically have to follow these same steps for all of the other referenced asset types. So that's going to have to be part of this change set too. Not the end of the world. But at least once we have that done, we'll have that done, and then we can just focus on the resource level stuff after all the asset work is done. So I'm okay with that. That being said, we are basically out of time for tonight. Let's see. Just posted a repo link here, got deleted. Links sometimes automatically get deleted by the bot if you post them. Bright Programmer, what I would do is if you want to post a repo link, we actually have a Discord server, and you can hop over on that, and there's a channel in there where you can actually post links to projects and stuff you're working on. So if you wanted to do that, that is going to be the way to do it, not in the chat here. Let's see. All right. Let me find somebody to raid. And while I'm doing that, oh, I know who I'm going to raid already. So we're going to raid Els Dragoon. They're a team of GigaChads working on a game in 6502 assembly on the original NES. So we're going to raid them, and I'm going to do it quickly before they raid me, because it's a bit of a contest. It's a thing. So enjoy that. Thank you guys for being here, and I will see you guys on the next stream. See ya.